Okay, here I have the walkthrough video for closure problem 8.139. It tells us to solve each equation or system of equations. Part A is an equation, and it might look a little bit intimidating because it has fractions, but it's really not that bad. My preferred way for solving this would be cross multiplying. So I would take my 5 and multiply my x plus 3. When I do that, I am left with 5 times the quantity of x plus 3. And we're setting that equal to 2 times the quantity of x minus 1. Make sure you use your parentheses if you are cross multiplying. Once we are left with this, the numbers outside of the parentheses need to distribute to everything inside of the parentheses. And we do that by multiplying. So 5 times x would give me a 5x plus 5 times 3 gives me 15. And that equals 2 times x, which gives me 2x, and minus 2 times 1, which gives me 2. What I would do from here is subtract 2x from this side, which gives me a 0 pair. And I know if I subtract 2x from this side, I need to do it from this side also. So I am left with a 3x plus 15 equals negative 2. As is the goal with any equation, we want to try to get the variable isolated or get it by itself. So I will subtract away my 15, which gives me a 0 pair, and I also need to do that on this side. So I am left with 3x equals negative 17. Now this 3x is actually a 3 times x. So to undo that multiplication, we need to divide by 3. And whatever we do on that side, we need to do on this side as well. That gets my x by itself, and I am left with just a negative 17 thirds. You don't need to do anything with that. That's not going to give you a nice number, so it is okay and actually preferred to leave it as an improper fraction. B is the system of equations. I think this would be easiest to solve using the equal values method. And to refresh your memory, the equal values method is where we take what y equals here and what y equals here, and we set them equal to each other to solve for x. So I would have 1/2 x plus 3 equals 1/3 x minus 4. I would add 4 to this side to get a 0 pair. I would add 4 then to my other side. I have to add it to my 3, so I am left with 1/2 x plus 7 equals 1/3 x. Now to get the x on one side, what I would do is I would subtract 1/2 x from this side and subtract 1/2 x from this side. That leaves us with a 7 and equals, if you aren't great with fractions, don't worry, you can just put it into the calculator. So you would have to do 1/3. You can't put x into the calculator. So again, you want to do 1/3 minus 1/2, and you should get negative 1/6 x. So we're left with 7 equals negative 1/6 x. So to get x by itself, we are going to divide by that negative 1/6. And when we do that on the right side, we also have to do it on the left side. So I'm going to put that into my calculator. 7 divided by negative 1/6. And I should get a negative 42. So that is what I get for x. Now we are not done with the problem because remember the solution to a system is written as an ordered pair and I have only found half of that. I have found my x. I now need to solve for my y. So I can do that by going back to one of my original equations. Either one is fine. I'm going to do the top one. So I'm going to do y equals 1/2. We're plugging in for x. Make sure you use those parentheses. Negative 42 plus 3. So again, you could put that into your calculator, and if you put it in, you would do 1/2 parenthesis negative 42 and parenthesis plus 3, and you should get out negative 18, which is what y equals. Now again, anytime we have a system, we want to write the solution as an ordered pair. So I would have negative 42, comma, negative 18, and that would be my solution to the system. That is all for problem 8-139.